charges and figuring out, let's figure out what these formal charges are. I'm sorry, oxidation numbers, not formal charge. So if we look at this lithium oxide, the first thing we have to do is identify what kind of compound is this. Lithium oxide is an ionic compound. It contains a metal and a nonmetal. So this is made of two monoatomic ions, a lithium ion and an oxide ion. So the lithium has a charge of +1, so the oxidation number will be +1. The oxide ion has a charge of -2, so the oxidation number will be -2. Now, in order to tell if we're talking about a real charge or an oxidation number, what I like to do is if I'm talking about a charge for the oxide ion, I write O2-. And if I'm talking about an oxygen atom in a compound, I write a -2. I write the charge, the number first in a real charge, and I write the sign first in an oxidation number to help me tell the difference. Now we think about this adding up business. 2 times a +1 is a +2. 1 times a -2 is a -2. When I add those together, they equal 0. So I have lithium oxide. Everything adds up to 0 because it's a neutral compound. Look at sodium hydride. This is an ionic compound, and it's a metal hydride. Sodium's a +1 ion, so it's a +1 oxidation number. Hydride is a -1 because it's a metal hydride. +1 - 1 is equal to 0. So those are fairly straightforward because they were ionic compounds. The next one is phosphoric acid. This one's not as obvious, and we have to figure out the phosphorus by difference. So as we go down the rules, we get to rule number 5 before any of them apply to this compound. Hydrogen is a +1 unless it's a peroxide, and this isn't. I'm sorry, unless it's a metal hydride. Oxygen is -2 unless it's a peroxide. I keep getting ahead of myself here. But I don't know any rules about phosphorus, so I have to find phosphorus by difference. So 3 times a +1 is a +3. 4 times a -2 is a -8. This is a neutral compound, so they have to add up to 0. So I have a +3 total for the hydrogens, a -8 total for the oxygens. What do I need to put in there to make this equal to 0? A +5. Now I have a +5 divided by 1 phosphorus, so phosphorus has an oxidation number of +5. Okay, this is hydrogen peroxide. So we go through our rules. Hydrogen's a +1. 2 times a +1 is a +2. This has to add to 0. So I need a -2 here divided by 2 is a -1. And you say, wait a minute, oxygen's usually a -2. But you have to do the rules in order, and the +1 rule for hydrogen takes precedence. So even if you didn't recognize that this was hydrogen peroxide, you would figure out by difference that the oxygen had to have a -1 oxidation number. Now, looking at the dichromate ion, this is the first example that's not a neutral compound. This is an ion. So whatever the numbers turn out to be, they have to add up to a -2 because that's the charge on the ion. So the dichromate, I don't know any rules about chromium. I know a rule about oxygen. Oxygen is a -2 unless it's a peroxide, and this is a dichromate ion, not a peroxide. So 7 times a -2 gives me a -14. This has to add up to -2, so I need a +12. +12 divided by 2 gives me a +6. So now I know the oxidation numbers for all of the atoms in the dichromate ion. Okay, MnO2. Well, this one can look at that and say, well, which manganese is it? It can't be manganese 3 because that wouldn't work out with oxygens. So it has to be manganese +2. So that means since I have 2 oxygens, I need a minus 2 total to add to 0. Negative 2 divided by 2 is a negative 1. Or perhaps you recognized that this is the peroxide ion, O2, 2 minus. That is one of the ions we talked about. Sodium hydride, it's the same as it was up there. Okay, perfluorate. Here we have fluorine always has an oxidation number of 1. So fluorine is a plus 1 times 1 fluorine gives me a positive 1. This is a negative 1 ion, so this has to add up to negative 1. So what do I need here? Minus 1. Fluorine is a minus 1. Thank you. So what do I need for it to be a minus 1 total? A 0. Negative 1 plus 0, so 0 divided by 4 is 0. So in this case, oxygen does not have a charge. Okay? Oxygen, this is unusual because it's usually a minus 2. It's a minus 1 in a peroxide, but here it's 0 because the rule for fluorine is higher up on the chart, so it supersedes that. Okay, SO2 gas. We don't know any sulfur rules. We know oxygen is a minus 2. This has to add up to 0. 2 times a minus 2 is a minus 4. So I need a positive 4 divided by 1 is a plus 4 for sulfur. Now, sometimes my students will look at this and say, how can that be a plus 4? Because normally sulfur makes a minus 2 ion. This is not a sulfide ion. This is a sulfur atom in a molecule. So don't let the oxidation numbers confuse you thinking of charges. Okay, and let's look at one more where we have to figure out chlorine by difference. This is a negative 1 charge. It has to total a negative 1. I know oxygen is a negative 2, so that gives me a negative 6. I need a positive 5 divided by 1 is a plus 5. So I can go through and assign oxidation numbers following those rules, and you have to learn to follow the rules in order or they don't make sense. Yes?